Hello everyone, welcome to this example here where we are exploring this particular problem, and this problem is also an example of how in certain 3D diagrams the north direction may not always be pointing upwards. Looking at this north arrow is actually pointing to a direction that is not upwards. Okay, in this diagram we have ABC, three spots that are on the same level ground. And we are also given some information like B is south of A. We are also given the bearing of C from A is 130 degrees and the length AC. So find the length of BC. Step 1, if I know this particular angle BAC, and with this configuration, how can I then find my BC? Yes, we are going to be applying cosine rule. So first, you do need to let people know that angle BAC is equals to 180 degree minus away my 130 degrees. Okay, this is adjacent angles on a straight line. So I will have 50 degrees here. And so I'm going to apply cosine rule where BC is the square root of 178 square plus 125 square minus 2 times 178, 125 times the cosine of 50 degrees. And this will give me 136.766 to about 6 significant figures, followed by 3 significant answer, 137 meter. The bearing of C from B. Okay, so since we are talking about the bearing of C from B, and B has the north arrow drawn already, ending line is BC. I'm going to use a different color. So I'm going to draw starting from the north arrow in a clockwise direction until it stops at the line BC. So this angle is the angle that equates to the bearing that we are going to find. So now that we have BC, right, we could actually tap on our knowledge of sine rule for this part. So for A part 2, I'm going to use sine rule, where I will have the angle, sine of angle ABC over 125 is equal to sine of 50 degrees over 136.766, which is my BC. And from here, I can then multiply 125 on both sides before finding my sine inverse of this multiplying by 125. This will give me a value of 44.4384, 44.4 degrees to 1 decimal place, and therefore bearing of C from B is equals to 0 for 4.4 degrees. Do take note, for all bearings, we do need to write it in 3 digits. Okay? So part A is done. Let's go back to the question. So I will look at what is for part B. Part B involves TA, which is a vertical building. At A, it is vertical to the land or the ground ABC, okay? Angle of elevation is given of T from B. Find the height. So now I wish to turn our attention to this purple triangle TAB. Since TA is a vertical building, this simply means that for B part 1, I would then channel my focus to this right angle triangle TAB, where I will have 23 degrees here, 178, and I'm supposed to find the height of this vertical building TA. Yes, we are going to apply Tuakaso now. Tuakaso. I'm supposed to find my TA, which is the opposite side. I have my adjacent side AB, O and A. Yes, I am going to apply tangent ratio to this question. Opposite over adjacent side, and I multiply 178 on both sides to obtain my TA. This will give me a value of 75.5565 to about 6 significant figures, 75.6 meter. Last, we will need to find the largest angle of depression of point P on the line BC from the tower T. So if I were to go back to this particular question here, right? It is important to take note that when they talk about largest angle of depression, we are generally looking at the shortest distance from the line BC, which translates to the perpendicular distance. So if I were to take out a ruler now, and if I were to draw a line from this vertical building, right? This point P has to occur here, where it is perpendicular to the line BC. Okay? And to bring your attention now as well, so there is this triangle TAP, which I'm going to highlight here in gray, in black. This will allow us to then find the angle of depression. But before that, step 1, I need to know what is the length of AP. Okay? So in order to find the length of AP, I'm going to tap on my green color right angle triangle here. Okay, this is also right angle triangle. So I'm going to draw triangle ABP now. At here, B part 1, step 1, triangle A, B, P. AB would be 178. I got my angle here. This angle is 44.4383 degrees. So what could be my APB? And at this point, right? Then this will be my hypo. This will be my opposite side with dua Caso again. I have my H and O. Yep. I'm going to use my sine rule, sine ratio. This will be equals to opposite over my hypotenuse. So therefore, I will be able to get my length AP. This is important, which is multiplying by 178 on both sides. This will give me a value of 124.625. To 6 significant figures. Then, now that I know my AP, then I can go back to draw my TAP now, okay? Which is a right angle triangle as well. So my TAP I got my AP 124.625. I got my height of the building 75.5565. Angle of depression of point P from point T is this angle, and this angle happened to be the same as angle APT by alternate angles. So this is my angle of depression. Right? And therefore, since we got a right angle triangle, what do you think we should use next? Yes, Caso now. So this will be my adjacent side, opposite side with respect to angle APT. So therefore, I will have my O and A. I'm going to use tangent ratio of angle APT is equal to opposite over my adjacent side. So angle APT will be the tangent inverse of this fraction. And that will give me a value of 31.227 to 31.2 degrees to 1 decimal place, and therefore the greatest angle of depression of P from T will be equals to 31.2 degrees. Well, with that, we have come to the end of this pretty long question. So if you like this video, do give it a thumbs up and subscribe to my channel. Thank you for watching and have a nice day while we continue to explore more mathematics problems.